Good afternoon, students. This is the 11th video of conductancy. We already studied the conductometric titration, and we also know what is the procedure, how the procedure takes, how the titration will occur. We also know the titration in which the end point or the equivalency point is determined by conductancy measurement is called conductometric titration. This is I know, and the procedure also you know that we have to take a conductivity beaker. We have to take a beaker means in which the electrolyte solution is, suppose electrolyte solution is put. This is the beaker, this is the electrolyte solution I put here, and in the burette the titrant, the titrant is taken. It was added in drop wise, and this conductivity, this beaker is called conductivity beaker, and in this beaker is electrode was put in it, conductivity cell, and the conductivity cell is connected to a conductivity B circuit, and from which you record the conductancy of the solution. That we know in the procedure. So okay, today we have to discuss about the titration of strong acid and strong base. We already did this experiment in our lab. That means the titration of strong acid, titration of strong acid, titration of strong acid and strong base, titration of strong acid and strong base. That means the titration between strong acid and strong base. We can do this titration using the indicator. We take the phenolphthalein indicator, or methyl orange indicator. Both are used in case of strong acid and strong base titration. So in phenolphthalein, you know, the color will change in colorless to pink color, and in case of phenolphthalein indicator, so you can also do. But in this case, we have to take a conductancy of the solution. We have to measure the conductancy of the solution. The conductancy of the solution present in the conductivity beaker. We have to measure using the conductivity cell. The conductivity cell is connected with a conductivity B circuit in which the conductancy is recorded. We already did this experiment in our lab. In that case, what we take? Now in this titration, the strong acid, such as hydrochloric acid, is taken in a conductivity beaker, That means this is a conductivity beaker in which we take the strong acid HCl. So in the beaker we take the HCl. The beaker which contains HCl is called conductivity beaker. The titrant, the strong base such as sodium hydroxide, is taken as titrant, in the burette. In the burette we take the titrant sodium hydroxide strong base. The base is added, the strong base, is added drop wise, to the conductivity beaker. We know that after each addition you have to stir the solution and note down the reading. This is, we already did this experiment in you add 1, 2 drop or 2 drop, 5 drops after each addition. Suppose in each addition you take the 5 drop. After each 5 drop you start the solution and note down the reading. That we we already did. In that case, the strong base is added dropwise to the conductivity beaker. The following reaction takes place in the conductivity beaker. The following reaction takes place in the conductivity beaker. What is the following reaction? Now H plus Cl minus, it is strong acid, so it is 100% ionization. So in the beaker, whatever the acid you take, all HCl is converted into H plus Cl minus. So in the burette you take titrant, sodium hydroxide. In the burette you take what? Now sodium hydroxide. Sodium hydroxide is also strong electrolyte. It is also undergo 100% ionization. So in the burette, sodium hydroxide is remain as Na plus OH minus, and in conductivity beaker, strong acid is remain as H plus Cl minus. When the reaction takes place, it is converted into Na plus Cl minus. It is also strong and converted into water. It is feebly ionized. That means when HCl combines with sodium hydroxide to form NaCl plus water, this NaCl in water converted into Na plus Cl minus. Okay, that means in this case what happens? Now Na plus NaCl product is formed. As NaCl is strong electrolyte, strong salt, it also undergo 100% ionization. So as it contains water, when NaCl you put in water, it does not remain as NaCl. It remains as Na plus and Cl minus. So this is my chemical reaction. Then what is the mechanism? Mechanism is that the H plus ions from HCl, strong acid, combines with OH minus ions from sodium hydroxide to form less ionized water. Then what happens? Now initially the conductance of the solution is very high. Initially, that means we have draw a graph in between which one? Now volume of sodium hydroxide you add, then conductance in millisiemen. Simon is an electrical engineer, noted in the electrical engineer. In his name, the conductance of the solution named as Simon. It is millisiemen. Okay. In the what happens? Now initially the conductance of the solution. Conductance means present in the water. The conductance of the solution. Is very high. Because HCl is a strong electrolyte. HCl is a strong electrolyte. So it is completely ionized. As we know that the conductance of the solution depends upon the number of ions. How many number of ions are there, their mobility and their charge. We already know that the conductance of the solution depends upon the three factors. One is the number of ion, one is the charge of the ion, third one is the mobility. So HCl is a strong electrolyte, so it is completely ionized. So the number of ion is very high. Second, this is the first stage, that is why the conductance of the solution is very high. Conductance of the solution is very high the conductance of the solution, this point. So second point is charge is H plus ion and Cl minus, charge is 1, and the mobility, third one. Mobility of H plus ion is very high. So initially the conductance of the solution is very high. So very high is the conductance of the HCl solution. So in the chemical reaction, the H plus ions combines with OH minus ions to form less ionized water. That means in the chemical reaction what happens? Now the H plus ion in the beaker, conductivity beaker present, combines with OH minus from the burette to form the water. Water is less ionized. We already told you that water is very less ionized because it has ionization constant. We already know 10 to the minus 16. So in that case one very less ionized water. So very weak electrolyte. So in the reaction what happens? H plus ion combines with OH minus ion to form less ionized. The mobility of the H plus ion, the conductance depends upon the three factors: number of ions, charge of the ion, and mobility of the ion. First you see that number of ion. The H plus ion, the mobility of H plus ion is very high as compared to Na plus ion. That means each H plus ion is consumed. Suppose 5 H plus ion consumed, 5 Na plus ion is formed. If 1 mole of H plus ion is consumed, 1 mole of Na plus ion is formed. So the number of ion will not change. Number of ion in the solution, in the beaker, we tell that conductance of the solution depends upon the three factors. One is the number of ion, second one is the charge of the ion, third one is the mobility. So each H plus ion is consumed, then 1 Na plus ion is formed. If 5 H plus ion is consumed, 5 Na plus ion is formed. 5 H plus ion consumed with 5 OH minus converted to 5 water. But at the same time 5 Na plus ion is also formed. So number of ion is not decreased. That means here H plus ion and OH minus ion, both two ions, suppose I consider that 1 H plus, 1 Cl, 1 Na plus, 1 OH minus. So 1 H plus, 1 OH minus combined to form the water, which is very less ionized, and Na plus Cl minus is formed. So in this case what happens? The mobility of the H plus ion is very high compared to Na plus ion. So as the reaction in progress, the concentration of H plus ion decreases and the concentration of Na plus ion increases. The number of mole of H plus ion decreases, the same number of mole of Na plus ion is formed. So that means number of ion is not so much, but depends upon the mobility of the H plus ion is very high as compared to the mobility of H plus ion is very high as compared to the Na plus ion. So during the reaction, during this reaction, H plus ion concentration decreases. At the same time, the Na plus ion cation, H plus ion cation, Na plus ion cation, at the same time Na plus ion increases in the same amount. So if 1 mole of H plus ion is consumed to form the water, 1 mole of Na plus ion is formed. So the number of cation will not change. That means 1 mole of H plus ion consumed, then 1 mole of Na plus ion is formed. No problem. Here also see that there are 4 ions are there, but here only 2 ions are there. Number of ion decreases, but main point is that mobility. The mobility of H plus ion is very high as compared to Na plus ion. As during the reaction, the concentration of H plus ion decreases, at the same time same amount of Na plus ion is also formed, but the mobility of Na plus ion is very less as compared to H plus ion. So the conductance of the solution gradually decreases. The conductance of the solution gradually decreases because the mobility of the H plus ion is very high, but its concentration decreases during the reaction, and the Na plus ion concentration increases, but its mobility is very less, and this process is continued. This process is continued till the end point is reached. Till the end point is reached, the conductance of the solution decreases because the concentration of H plus ion decreases. The mobility of H plus ion is very high as compared to Na plus ion. The same amount of Na plus ion is formed, but the mobility of Na plus ion is very less as compared to H plus ion. So the conductance of the solution decreases. After the end point, the conductance of the solution increases. After the addition of sodium hydroxide, then why it increases? Because that means whatever the Cl is formed, that was consumed and converted into Na, combined with Na in sodium hydroxide, converted into Na plus Cl minus, and water is formed. So all H plus ion is consumed. So when the reaction is neutral or after the end point, what happens? Now when you add sodium hydroxide from the burette, when you add the sodium hydroxide from the burette, then what happens? Now there is no H plus ion is there, so it do not combine with OH minus. So whatever the concentration is there, they are the sodium hydroxide. The mobility of OH minus is very high. So the after addition of sodium, after the end point, further addition of sodium hydroxide, the conductance of the solution increases. The conductance of the solution further increases. It increases in this process. If the conductance of the solution decreases, like AB, it is the C, suppose D. So after the end point, the conductance of the solution increases after addition of sodium hydroxide, because the conductance increases. The conductance increases after the end point. After end point, because the mobility of OH minus because the mobility of OH minus is very high. There is no H plus ion, so it is not neutralized, but all H plus ion is consumed. That means reaction is over. So when you add further sodium hydroxide, it remains as Na plus OH minus. So two ions are formed, Na plus OH minus, but the mobility of OH minus is very high. So the conductance of the solution increases because the mobility of OH minus is very high. The intersection of the two straight lines, the intersection of the two straight lines, the intersection of the two straight lines is called the end point. The end point or equivalency point. That means the end point is the point. The end point or equivalency point is the point. End point is the point or end point or equivalence point is the point where the conductancy is very low. Where the conductancy is very low. So end point is the point. So end point is the point where conductance is very low. So a graph is plotted. Between the volume of sodium hydroxide and conductancy of the solution. So when a graph is plotted, we already saw that when the graph is plotted, what happens? Now first, conductancy is very high because HCl is a strong acid, completely ionized. So when sodium hydroxide we add from the burette, it combines with H plus ion to form the NaCl and water. Each H plus ion is replaced by Na plus ion. As the mobility of H plus ion is very high as compared to Na plus ion, so the conductancy of the solution gradually decreases. So conductancy, this point we get, this conductancy of the solution increases. After the conductancy end point, further addition of sodium hydroxide, the conductancy sharply increase because this is the point. Conductancy sharply increase. Then because the mobility of OH minus is very high, so when we draw a straight line, the intersection point is reached. Suppose this intersection point, I put here X, this point is called the end point. So when you draw a line, what is the volume of sodium hydroxide consumed is called the amount of sodium hydroxide consumed that for the HCl that is present in the beaker, and that amount, from that amount you know that what is the concentration. That means N1V1 is equal to N2V2. You know the concentration. If you unknown, your HCl is unknown but sodium hydroxide is known. Basically we find out the concentration of sodium hydroxide because it is a secondary standard. HCl concentration I can sharply measure. So if you take the concentration of HCl is known, volume of HCl is known, N1V1. N1 is the concentration of HCl, V1 is the volume of HCl that you take in the beaker with 50 ml of volume. Suppose this is equal to 50 ml. With 50 ml, suppose concentration is 0.01 normality, then number of equivalent is N1 into V1. 0.01 50, and 2 V2 you know what is the amount of sodium hydroxide consumed from this graph. From this graph you know the V2, then you can find out N2, what is the concentration of the sodium hydroxide you have taken in the burette. You have find out N1 V1 is equal to N2 V2. V2 you take from the graph. Okay. In this way, the conductancy of the strong acid, strong base we have to consider. Second is the conductancy, titration of strong acid, weak base. Titration of strong acid, weak base. Titration of strong acid, weak base. Same formula. We also did this experiment in our lab. You also did this experiment all in this lab. Conductancy measurement. The same process, same method. Only graph is changed. You have to take them in this titration. In this titration, strong acid. In this titration, strong acid, such as HCl is taken in the conductivity beaker. In the conductivity, taken in the conductivity beaker. That means in the conductivity beaker you take HCl. It is strong acid, then weak base, and weak base WEAK, and weak base such as ammonium hydroxide is taken as titrant. Taken as titrant in the burette. Taken as the titrant in the burette. The ammonium hydroxide is added dropwise. The ammonium hydroxide is added dropwise to the conductivity beaker. The same method, same process. Conductivity beaker. The following chemical reaction, takes place in the conductivity beaker. In the conductivity beaker. The following chemical reaction takes place in the conductivity beaker. How? Now HCl, it is a strong acid, so it is converted to H plus Cl minus, but ammonium hydroxide is a weak base. It is not 100% ionized. So I cannot write NH4 plus OH minus. I write NH4 OH because it is a weak base. It is not undergo 100% ionization. But HCl is a strong acid. It undergo 100% ionization. So I write H plus Cl minus. Ammonium hydroxide is a weak base. So only 10% or 5% ionized. So in that cases we have to take what? Not weak base. Here we write equilibrium point because the chemical reaction can be backward direction due to common ion. I will tell you that during the cases what happens now. Ammonium chloride is a salt. It is completely ionized, and water is a very weak electrolyte, very less ionized. Okay, this is the my cell reaction. This is the cell reaction. इतने टाइम है जो हवन time. Okay, this is in the cell reaction. I just tell you in the next class I will starting from this point. Here is the HS, that means initially the conductivity of the conductivity is very high. Conductancy of the solution, in this case initially the conductancy of the solution is very high because the HCl is completely ionized. So mobility of H plus ion is very high. So the conductance of the solution is very high. So when ammonium hydroxide is added, the H plus ion is consumed and it converted into water. Water is less ionized but weak electrolyte. So as the H plus ion is concentration decreases, NH4 concentration at the same time increases. If it is 1 mole decreases, it is 1 mole is formed. But the mobility of H plus ion is very high as compared to NH4 plus ion. So after each addition of ammonium hydroxide, the conductance of the solution gradually decreases. The conductance of the solution gradually decreases. This is the conductance. Conductance millisiemen. This is the volume of ammonium hydroxide. Okay, initially conductance is very high because the mobility of H plus ion is very high. So after that, after each addition of NH4 plus, H plus ion consumed, concentration of H plus ion decreases. At the same time, concentration of NH4 plus ion also increases. So if it is 5 H plus ion decreases, 5 NH4 plus ion increases. If it is 2 mole decreases, 2 mole increases. But the mobility of H plus ion is very high as compared to NH4 plus ion. So the conductance decreases. After the end point, then what happens? Now the beaker contain whatever you add, it is remain as ammonium hydroxide. Because here NH4Cl minus, it is a strong it is a salt, it is completely ionized. Due to NH4 plus Cl minus ion present, the dissociation of ammonium hydroxide is not possible. At all is not possible due to common ion effect. Here NH4 plus ion, if NH4OH is dissociated, converted NH4 plus, so NH4 plus, it is a common ion effect because NH4Cl 100% ionized, converted NH4 plus Cl minus, but ammonium hydroxide, it is a weak electrolyte, converted NH4 plus OH minus. So whatever NH4 plus is formed, it is again moved to the backward direction because this is the common ion effect. Because NH4Cl is a salt, 100% ionized, you cannot check it. But NH4 plus ion, NH4OH is very weak. So once NH4, though some 1% or 10% ionized, but due to presence of common ion effect, is completely reversed back. So further addition of ammonium hydroxide does not increase the conductance of the solution. It just remains parallel. From parallel to slightly decreases because NH4OH is not ionized at all. Do not ionize at all. Because due to NH4Cl. NH4Cl is a salt due to common ion effect. Whatever ionized, 1% or 2%, it is reversed back. So after the reverse back, it is 0% ionized. Does not ionize, 0% ionized. So ammonium chloride is formed, though its mobility is very less, so the conductance does not increase. So the conductance slightly decreases from the parallel, slightly decreases. Suppose this is the point A, this is the point B, this is the point C, this is the point B. This point is the intersection point, which is called the end point. Whatever the volume consumed from N1, V1, N2, V2, you have to find out the concentration. In the next video, I upload the mechanism. Okay, thank you.